This is Kevin. I'm a software engineer at Google and a graduate of the EECS program at UC Berkeley. Go Bears. And today I want to talk about LeetCode problem number 5, longest palindromic substring. And this is a medium difficulty problem. And cool. So basically, the problem says you are given a string and you want to find what is the longest substring or like a portion of the string that is a palindrome. And a palindrome is a string that is spelled the same forwards and backwards. So BAB, right? If you reverse this, it's still BAB. So, for example, like race car, very popular palindrome, right? If you flip this around, it's still race car. You add a Z to it, now it becomes not a palindrome, right? This backwards is now this, so that's what a palindrome is. Cool. So I think it's pretty simple how the problem works. All right, and I was taking a look at also some of the solutions here, and just want to I see that there's a lot of kind of complicated ways of going about this. Like this first solution has, S prime, all this weird corner cases, and it's dynamic programming. This brute force one is n cubed time complexity, so it's pretty slow. This one is n squared and n squared space. The dynamic programming one, n squared time and space. But this one right here, the expand around center, this one is n squared time and space complexity is 1. So it's basically got the best complexity analysis. And in my opinion, this is the easiest to understand of the 4, so I don't know why you would even go for one of the other ones. Runs the fastest, least amount of space, and is easier to understand. So we're going to go with this one. I'm only going to explain this expand around center one. Approach number 4. There are other problems for DP, dynamic programming, that are, in my opinion, a better fit for DP. So, there's other videos in my channel that you can check out, or eventually I'll put up that are about DP that would be a better fit for that. Different problems that would be a better fit for that. But I think for this problem, this expand around center is the most intuitive approach. Before I dive into this, though, they also provide a manager's algorithm, they say, which is a time complexity of O of n, which is actually really, really good for something like this. If you were to look at the problem intuitively, it wouldn't be very obvious, that there's actually even an O of n approach to this. I took a look at what this is. It's very complicated. And so I would not recommend wasting time. I don't want to say wasting time, but I don't think it's worth the effort to learn this right now. And let me explain what I mean by that. So I think the first thing we're talking about is which approach to use, right? DP, intuitive, expand around the center, and then managers. And this is big O of n squared. And this guy is big O of n squared as well, but better space complexity, and this one's big O of n in terms of time. All right, so probably for a lot of people out there, the goal of doing LeetCode is to be ready for an algorithm interview and ultimately to get the job at a big tech company, get paid. So usually how that works is you probably have something like a phone screen first. Generally in the phone screen, you'll be asked a question. So let's talk about the process for a second. Interviewing. You're going to start with a phone screen, and then if you pass the phone screen, you do an on-site. And the phone screen is going to be usually just one question, and it's going to be moderate difficulty. And so for the phone screen, if you do end up getting this problem, I think it's the chances of them expecting you to do manager's algorithm, it's just overkill. It's just too complicated. And it's actually really high risk for you to use that algorithm in the phone screen because there's a pretty big chance you'll make an error or you won't remember it that well, or like it's gonna be too complicated. And so if you so the phone screen is a really binary thing. It's really just to say yes, no, should we invite this person on site? And so you don't even really need to blow it out of the park. You just need to just not make any mistakes. That's what it's really about. So if you take this manager's algorithm and do it in the phone screen, you're like, it's really risky because it's easy to make a mistake on such a hard problem. So I guess that's a hard approach. So that's basically the main thing about it. So I wouldn't recommend manager's algorithm for the phone screen. Now for the on-site, it's usually multiple algorithm coding sessions. It could be 2 to 3 to 4 to 5, just depending on the company you're interviewing with. And then how they would look at that at the end of the day is, okay, well, this person did 4 algorithms. Out of the 4 algorithms, they did great on 2, and they did okay on the other 2, for example. That could be one analysis. Or it could be, on the 4, they did really great on 1 and okay on 2, and the last one, they just bombed it. And, in preparing for the on-site, you're going to get a broad distribution of types of algorithm questions. Like the company wants to find out, do you have the breadth of knowledge and have approached different types of questions. And so deep diving into one approach too much could actually mean that you end up not spending enough time prepping other topics. It's better to have more breadth here. And so that's why, again, I don't think that manager's algorithm is really great for interviews, just because it's too complicated. The amount of effort you put in, it's actually, I think the time is better spent prepping and learning more breadth, or getting better at, knowing this type of algorithm, the expand around center approach a little bit better, and be able to explain it more clearly. So that's kind of my rationale why, for now, I'm not going to really go into this manager's algorithm. But if you feel strongly about it, leave me some comments, and I'm happy to make a follow-up video talking about that. And I can also, and DP as well. If people are interested in DP, I'm happy to make a video about DP. I probably use a different problem, though. This isn't in my opinion, a great example for DP. Okay, cool. So we're going to do this expand around center approach. And this approach is actually pretty intuitive. I really like it. So basically what the approach is like, so number 3, our approach. Basically how it works is we're just going to, let's say we have this string, babad. It's just going to, given a string to find the longest substring that's inside of it, you can actually just start from some center point and expand out until your substring is no longer a palindrome. So for example, B by itself is a palindrome, and then you go out to one letter on each side, A, B, A, and again, that's a palindrome. And then you expand again to add one more letter on each side, and B, A, B, A, D. Okay, well, B and D are not the same, so that is no longer a palindrome, so we can stop expanding out. And so for each center point, you can basically find the biggest palindrome just by expanding out from that middle section, right? And it's pretty simple. And you would basically expand out until so what are some conditions? So, okay, so here's going to be our approach. So expand out from a middle letter. And when will we stop? Stop when when 2 letters are not the same, right? Like we saw, B and D are no longer the same. Or we would stop when we hit the edge of the string. There's no more letters. Like let's say we were here, A, we expand out to A, B, B. Then we expand, we can't go to the next one. So B, A, B is the longest if A was the center. And yeah, that's basically all there is to it. It's pretty simple. You just expand out from a middle letter until the letters are not the same or you hit the edge of the string. And then here they give you another example just to help illustrate C, B, D, D. And this one we could, if you actually start from each individual letter, you expand out, you actually would only get a bunch that are only one. You can't expand out and find one, but palindromes could actually have a center point, which is, so if we expand out from a single letter, we were only getting the odd letter, the palindromes with an odd number of characters. So we can also start from having 2 letters in the middle, and this would cover all the palindromes with an even number of characters, so BB. So actually let's kind of show this a little bit. Odd, even, right? If we start, so basically what we could do is we could have 2 pointers, a left and a right, starting on B, and then they would expand outward. Oh, okay, we already hit the edge, so the biggest substring is 1. For even, this one doesn't actually, basically we would start with our pointers on L and R, right? And, oh, they're already different, so the substring is going to be 0. And, okay. And then then we would move on to the next letter, A, and we would have both of our pointers left and right here. Okay, it's fine. A is the same as A, and then we move the L over to here, the R over to here, right? Now they're the same as well, so again, we're good. So now we're up to a palindrome of 3, and then we move the L over to the end. Oh, look, we're off the end of the string, so we can't check anymore, so 3. And so we can kind of like fill out this table the same way. This one would be 3, this one would be, this one would be 1 and 1. And so then from each middle section we can find the best, the longest palindrome that is an odd number of characters, and the longest palindrome which is an even number of characters, which is actually 0 in every case in this one. And then from there we just find the global maximum, 3 in that case, and output that. So pretty straightforward. And then for this case, now in this one, the odd case is actually going to just be 1 for every case, because there's no actual odd middle palindrome, but for the even it becomes a little more interesting. So even, our pointers are going to be on L, and our left and right are going to be on C. Okay, I'm sorry, actually C and B. Oh, nope, that's not 1. Okay, have our middle pointers be on L and R. Okay, they're the same, so that's at least 2, and we expand this out. Oops. L goes to here, R goes to here. Oh, C and D are not the same, so 2 is the biggest. And so we can kind of fill the rest of this out like that. All right, so, and then again, our global maximum is 2, so this one is, there's a sub palindrome at 2, which covers the whole thing. So that's basically the main gist of how would we expand out from a center point, and as our algorithm. So why don't I go ahead and code this up, make it a little more concrete for you. This might be too abstract and hard to follow along. Let's see some code. All right, so how will this work? Okay, so let's start with, I'm going to have a little helper function here called longest at index. And it's going to be passed in the initial starting string s, so basically our thing just has s here, right, the string, and a left and a right index that I was kind of showing earlier. And what we'll do is, while something, we're going to keep expanding out. So the left index goes to the left, the right index goes to the right, and the L and R are going to be initialized at some middle point. And then we're going to return something. All right, so when will we stop expanding? One is if, well, the character at the left index and the character at the right index, they have to stay the same. So if they're not the same, then we would break out of the loop. So while they're the same, we keep expanding, right? And that's this. So this is to say when we stop. So we would keep going if they are the same. So if they're the same, we keep going. Another reason we would stop is if we hit the edge of the string. So if we don't hit the edge of the string, we keep going. So that's basically L is greater or equal to 0, which is the bottom edge of the string, and then R will have to be less than length of the string. Okay? And so that's just saying, okay, well, the left index, as it keeps going to the left, as long as it stays within, this is the 0 index, it doesn't go any further, you're good. And if you're going to the right can't go off the end of the string as well. And we have to do this part actually first before we do the character checking. This is just like, because if we go off the end of the string, and then we do s at a specific index, we would get an error. So this also protects us from pulling characters that are off the end of the string, and we won't have any errors if we do the check first. And so as we expand out like this, let's just take an example again. A, B, A, for example. So, L and R are both on B, right? And then they expand out to here. And, okay, that A and A are the same. And then they expand out again, right? Then we minus 1 from L. And we plus 1 from R. And then we're off the end now. So this while loop will break. But our string actually is from one L that's previous to that and one R that's previous to that. So we'd actually, after we finish our loop, we would then just add 1 back to R and minus 1 from, or add 1 to L, minus 1 from R to get us, this L goes back into here. So they actually represent the ends of our string. And that may, believe me, I thought about this for a while and try to see like how can we make this more clean. I think this is the cleanest way to represent it, and it's the most intuitive way. So that's how it is. And now, ultimately, we're gonna now we want to return these indexes. So, and actually, we also want to. I think it's also good to have the length itself because we want to compare the maximum length against the global maximum. So let's do it like this way. We're gonna have return your length, left index, and then left index, right index, like that. So I'll create a tuple and return all 3 of those. So it's gonna be, what is the length? It's gonna be R minus L. And these are actually, let's say it's this string right here. R would be 2, L would be 1. It would be a length of 2. It's actually 3, so just add 1 to that because it's just the way the math works out. And this actually isn't really that important because we just need to know if this is bigger than some other one we checked. So if we calculate it the same way with or without this 1, it doesn't really matter. But just for the sake of understanding what's going on, I'll just add the 1 in there. And then we give the left and right indexes, which we got the right indexes from this. So this is our little helper. So from basically what this does is that any middle index, if you expand out, it'll give you the best string, palindrome string, the longest palindrome string, and give the indexes of it. It won't actually give you the string itself, and I think it's better to pass the indexes. The reason why I pass the indexes here is because if you actually take the string and pull the substring out, that's actually another end time operation, so you don't want to do that. You just want to pass these indexes. This is a constant time operation, just getting the indexes. And then at the very end, we can pull the string out. All right, now let's we have to just iterate through the whole string. So for I in range, length L R, right? Our length, our left index, our right index, equal to longest at index of S, our starting string, and the left, and so I is basically going to iterate through each index, and then we're going to use that as your starting left and right strings, and then if length, so let's also keep a longest. Our longest we've seen globally, our left index right index. Actually, let's make this -1. I'll explain why later. So if the length that we are seeing locally is greater than our longest length, then we do longest now equals this length. Left equals L, right equals R. Cool. And then for this situation, we're just basically taking I and we are using it for both the left and the right index. So this is saying we're going to be starting on the same character and expanding out from the same character. So this is really the odd case, right? This will only find the number of palindromes that have an odd number of characters. Now let's also make sure we do it for I+1. Oops. Why does it always do that? Okay, I+1. Length is longest. Oh, we can just copy this whole part down, actually, so this is the same. Right. And this will be the even case, and that's basically saying, like, okay, we'll have L start on one letter, and then R start on the letter after it. And we have all of our error checking to make sure we don't go off the end of a string. So we're fine if we just, let's say we're at the last index of I, we go off the end. It's fine. This will still catch it. And that's basically it. And then after we finish this for loop, we should return. We're going to be left with our indexes. Our left and right indexes should be the index of our longest string, so then we can just go ahead and return s from left to right plus 1. And let's go ahead and try that. All right, cool. So it looks like it worked. Let me just submit this, make sure it works. Yay, okay, it worked. Let's see here. One thing, let's see what I was going to call out. Oh, okay. I talked about this, the right -1 thing. Let's just think about what would happen if you were to be given a test case that is an empty string. So you would essentially, you would get to here, you would actually not even enter this, right? Because len s would be 0, so you would not enter this for loop. And then you return s from left from 0 to right. And so if this was 0, would do 0 plus 1 would be from 0 to 1. Oh, that might actually still be okay. That's probably actually fine. It doesn't really matter. I just wanted to highlight the case that in the interview, you should just make sure to test this corner case. If you are given an input of an empty string, what does it return? In our case, it returns empty, so that's fine. Good. Cool. And then I guess this is super minor, but these two parts are basically exactly the same. So you can actually even factor this a little bit more and just say for j in x range 2. Python, this is just going to go up to 2, 0, and 1, and exclude 2. So that's what this is. And then we'll take this, all right, move everything over. And this will be I plus j, right? That's the only difference. So it's a little bit cleaner, I guess. It's just saying, like, okay, for each middle index, you will test it with where left and right are both I, and j could be 0 or 1, so they're the same. And then when j is 1, then it'll be that character plus the character to the right of it will be the middle point. And then we'll do this thing. So I'll just submit that, make sure it works. Cool. Looks like it's working. Cool. So let's. This is basically, if you get to this, you explained everything clearly. I think this is, you should be fine for this type of for this question. Oh, actually, let's see. One other point I was going to cover. In this example, it says you get BAB or ABA is valid. I mean, this is a small curveball, but they could potentially throw this to you, like how can you get your code to output BAB or ABA? And so what this is really asking is, BAB is the first time you see the longest one, ABA is the last time, right? So let's actually just take this guy. And right now we have it, and that's really controlled by this. Whenever our length is greater than the longest, that means each time we see one that is actually bigger than the last one we saw, then we would replace our global maximum. So this will give us the first one, the first instance of the longest one. So that would be BAB in this case. So let's show that. And if we just change this to greater or equal to, then each time we see one that is greater than or equal to, so as long as the longest one we've seen, then we will output that. So this will give us the last time we see the longest last time we see the longest palindromic substring. So that would be ABA in this case. This is basically just, we keep on seeing ones that are length of 3 long, and so the last one we see that is length of 3 long will be the output. So I'll just show that. This will give us ABA. Cool. Which one's better? I mean, I think probably this is better. Less operations, but I mean, just so you just understand like that you can kind of control that. So if an interviewer asks you, then that's how you would control that. And let's talk about space and time complexity. So for this one, essentially what you would do is you're iterating through, right? You're going to do this for loop, one operation through here, through each character. And actually there's 2 operations, so that's going to be 2n. Well, drop the constant, it's n. And then here we do this expanding thing. And this expanding thing could actually take up the entire, it can expand out through the entire string. So this is again another n-time operation. So this ends up being 2n for this part, and this one is n. So that's 2n squared, which is n squared. Drop the constant. Space, constant space, right? We don't actually use any other data structures. We just update these 3 variables. It's constant. Nothing is growing with the size of the input, so space is constant space. Cool, so that's basically this solution. Here's the code. Here's our kind of like overview of the stuff. Here's our time and space complexity. Hopefully that was helpful. If you have any follow-up questions or a particular topic that you would want me to cover in more detail, leave me some comments and I'll go ahead and cover those in a follow-up video. Or if there's a specific question on LeetCode that you want me to cover, again, feel free to leave some comments and I can follow up with a new video on those questions. All right, thanks so much for watching and best of luck in the interviews.